I'm introducing an electronic component that can be used as a voltage controlled voltage device. It is available in the form of an integrated circuit. So the popular one, this is called operational amplifier in general, and a popular IC is 741. So it's something like this. There are this is 8 pin IC, 1 2 3 4 2 3 4. So pin 1 2 3 4 here, and 5 6 7 8. So pin 1 pin 2 and 3, these two are inputs, and these two inputs have a polarity. So pin 2 is the inverting input. So when an input voltage is applied there, the output is inverted, and pin 3 is non-inverting input. So when an input voltage is applied here, the output is not inverted, it's the same. And this is the output pin. And pin 7 is the positive bias, positive VCC if we will, and then pin 4 is negative VCC. Anyway, these details are not important at this stage. This is just the practical pins. The symbol here is, if we do the ideal one, I can draw the ideal operational amplifier like this. So these two are the input pins, this is the output pin, this is bias pin, pin 7, pin 4, this is 2, this is 3, and this is 6. Now for the real one, I can draw it like this. So this is the input resistance here, and then we have, so I am drawing the IC like that, and here we have, let's say this is ground, and then we have a voltage controlled, I don't know, this doesn't look, it's a bit clumsy, so I will draw a voltage controlled voltage source basically like that, and then it goes here. So this is V0, and this value is, say, VD V2 minus V1 times AD. So AD is the gain, and this is V2 here, and this is V1 here basically. So this one is just like that. If I say this is VD, this is VD like that. So that's the polarity. So basically it's inverted, because this is where this is the pin 3 and this is pin 2. So that's that. Now in terms of values, the input resistance is very high normally, and for practical reason it can be often used as an infinite, and the output resistance, so Ri is infinite, but it is actually of the range of, let's say, 10 to the power 5 to 10 to the power 13 ohms, and the output resistance is very small, it's like 10 to 100 ohms, but for practical purpose it is often used as 0. So these are the ideal values, but this is precise. Often it is used, it is fine to use these values in circuits. So like often we use a voltage source as an ideal voltage source like that. So these are the ideal values, and the voltage gain is infinite, but of course it is limited by the value of the bias voltage. So bias voltage for 741 is 15 volts, but for different op amp it ranges from 5 to 24 volts. So those details are not important. Depending on the IC, we can use that, but the gain is limited by the voltage, saturation voltage. Normally the gain is very high, it's 10 to the power 5 to 10 to the power 8 like that, the voltage gain. So that's the open loop voltage gain, but depending on the value of the voltage source, it's limited by the supply voltage, it's limited by that. So basically the voltage is, so the output voltage can be written like that. So this is the gain here, and this is V2 minus V1. So if I draw the output voltage, it can be like that. So basically this is the gain here where it's linear, but when it reaches the supply voltage value, this becomes it doesn't change anymore. So we can get a square output basically using an op amp if we drive it, if we drive the input voltage large enough so that it goes to the saturation level. So we can have a sinusoidal input, and because it reaches wherever it reaches the saturation voltage, that is the bias voltage, we can get a square output like that. So yeah, that's what it is. It's a very brief introduction. I will do more, and we can use this operational amplifier as a differentiator, as an integrator, as an adder, and of course as an amplifier. So I will do some circuits later on.